Hi, good evening, and today I will be presenting about product or manufacturing system that represent the mechatronic devices. Okay, so first of all, my name is Govinash Analaki Murugan and my number metric is 09DEM 20F 2032 and I am from the class DEM 3. Okay, so today I will be talking about the 3D printer. So a 3D printer is a digital file can be used to create three-dimensional solid things via additive manufacturing, also known as 3D printing. Utilizing additive methods, 3D printed objects are produced. In an additive process, an object is made by adding layers of material one after another until the product is made. It is possible to think of each of these levels as a finely sliced cross-section of the object. Subtractive manufacturing, which involves hollowing out a piece of metal or plastic using a milling machine, is the reverse of 3D printing. With 3D printing, we can create intricate shapes with less material than with conventional production techniques. So the sensor that is used in the 3D printing, one of the sensors that is used in the 3D printing is the thermistor sensor. So a thermistor is an important component in FDM printers. So before we talk about all of the thermistor's function, let's see what is the definition of the thermistor. So thermistor is a short form of thermal resistors. The thermal resistors are an electrical device whose resistance varies with temperature. There are two types of thermistors. The first one would be NTC, that is negative temperature coefficient thermistor, and the second one is the positive temperature coefficient thermistor. So the first NTC, which means negative temperature coefficient thermistor, is a thermistor whose resistance decreases with increasing temperature. So if you use NTC, negative temperature coefficient, the thermistor's resistance will be decreasing, while if the temperature is increasing in the product we using the thermistor. So whereas the positive temperature coefficient thermistor is a thermistor whose resistance increases with an increase in temperature. So the resistance of the PTC will increase while the temperature of the product we use the thermistor on increases. So the sensitivity of the thermistors to change in temperatures make them suitable for temperature sensitive applications. These applications include circuit components and digital thermometers. So this is the NTC transistor. So thermistors in 3D printers serve as temperature sensing devices. They are found in temperature sensitive areas like the hot end and the heated bed. In these areas, they monitor the temperature and relay the data back to the microcontroller. The thermistor also serves as a control device. The printer's microcontrollers uses the thermistor's feedback to control the print temperature and keep it within the desired range. So most of the 3D printers out by now are using NTC thermistors to control the the temperature and the areas that should be using the temperatures in the sensors. So the data acquisition, the process of digitizing data from the environment so that it may be presented, examined, and saved in the computer is known as data acquisition, or DAQ as it is frequently called. A straightforward illustration is the process of utilizing a sensor like thermistor to measure the temperature as a digital value. Network connectivity software for data analysis and reporting, and possibilities for remote control and monitoring can be added to modern data gatherings. So the diagram below shows the data acquisition procedure of 3D printers. Building the plate surface adjustment. So the next step would be the preheat extruder, and then collect AE and PE strain sensor for 10 seconds. So if the process is completed, print about the print time would be about 28. It depends on the 3D model we will be printing, or if not, we should be waiting for another 5 minutes. So that is all for me today. Thank you.